Find the nth term of the Arithmetico-Geometric series. Let us begin. So here we have a series that has the first term as 1, next term will be negative 3x, well followed by 5x squared, then negative 7x cubed, and the rest of the term. Now, since this is an Arithmetico-Geometric series, clearly it means that it's composed of two types of sequence. One will be in arithmetic progression and the other will be in geometric progression. Now, what we'll do? We will try to rewrite each of the terms. So, the first term can be expressed as the product of 1 with 1. Then, the next term we can express it as take 3 and multiply it with negative x. That will get added to 5 times x squared. Add to 7 multiplied to negative x cubed, and so on. Now, clearly, what we'll do, our next task will be to extract the two types of series. So, let us suppose that let 1, 3, 5, 7. So, here we are considering the constant coefficient terms. So, let's say these are in arithmetic progression. Now, if they are in arithmetic progression, then we can define the nth term, which has the formula given by a plus n minus 1 times d, common difference d. Then the first term, that's going to be 1, added to n minus 1 times the common difference. Now, to find out the common difference, if we take any term and subtract the previous term from it, it should give us a fixed constant value. So if we do 3 minus 1, that's going to give us 2. 5 minus 3, that also gives us 2. 7 minus 5 equals to 2. So that means this sequence is indeed in arithmetic progression. So that means a common difference is going to be 2. And when we simplify this, we're going to get 2n minus 1. So that's going to be the nth term of the arithmetic progression. And we're also going to consider n also let the coefficient of the constant term that we just took. So that will be, for the first term, we'll have 1. Next will be negative x. Then we have positive x squared. Then we have negative x cubed, and so on. Now, these particular terms are going to be in geometric progression. Now, let's verify if they are in geometric progression or not. So that means we need to have a fixed common ratio. So if we take the second term, which is negative x, and divide it by 1, and we see that this is exactly the same as taking the third term and dividing it by the second term, which is also going to be equals to taking the fourth term and dividing it by the third term. So it's always giving us a fixed ratio, which is negative x. So that means the given sequence is going to be in geometric progression. Then we can define the nth term as a multiplied to x r, the common ratio, raised to the power of n minus 1. So substituting the value, our first term, that's 1. The common ratio, that's negative x. So we have negative x raised to the power of n minus 1. Or what we can do, we can pull out the negative 1 from the inside the parentheses. So we get negative 1 raised to the power of n minus 1 multiplied to x raised to the power of n minus 1. Now we have successfully obtained the nth term of the arithmetic progression as well as that of the geometric progression. Now we are ready to find out the nth term of the Arithmetico-Geometric series. So an is going to be equals to, we'll take the nth term of the arithmetic sequence, so that's 2n minus 1, and multiply it with the nth term of the geometric progression. So that's negative 1 raised to the power of n minus 1 multiplied to x raised to the power of n minus 1. Now let us verify. Let's say we consider n to be equals to 3. Now for n equals to 3, a 3, that's going to be equals to, we have 2 times 3 minus 1. This will get multiplied to negative 1 raised to the power of 3 minus 1 times x raised to the power of 3 minus 1. So 2 times 3, that's 6. 6 minus 1, that's going to be 5. Negative 1 raised to the power of 3 minus 1, that's squared. So negative 1 squared, that's positive 1. That will get multiplied to x raised to the power of 3 minus 1, that's 2. So that means the third term is 5x squared. And this is indeed matching with the original series. So that means the nth term of the Arithmetico-Geometric series will be 2n minus 1 times negative 1 raised to the power of n minus 1 times x raised to the power of n minus 1.